Welcome back to another episode of WAPSI. Let's move on to our question. So, the first question, the oxide of a potassium that does not exist. Yes, we'll discuss. What are the oxides? The only oxides that can be formed here are actually K2O, which is potassium oxide, right? Here discussed the oxides of alkali earth metals, right? Alkali metals. And KO2 is potassium peroxide, right? And K2O2 and KO2, potassium superoxide, right? So these are the three oxides of potassium that are formed by potassium element. So the correct answer would be K2O3, which is not an oxide of potassium. Okay, shall we move on to our next question? Here we have a 0.4 gram of dihydrogen is made to react with what? 7.4 gram of dichlorine to form hydrogen chloride. The volume of hydrogen formed at 273 Kelvin and 1 bar pressure is. Okay, this is what our question is. Okay, when a dihydrogen, which means H2, is treated with 7.4 gram of dichlorine, we get HCl, hydrochloric acid, 2HCl, right? So the balanced chemical equation for this statement is given, and the volume of hydrogen formed at, we have to find out the volume of hydrogen formed, right? So we could discuss the number of moles used here. Here the given mass of hydrogen is 0.4 gram with 2 moles. Am I right? Yes, 2, which gives 0.2 mole, and chlorine 7.1 given mass by molecular mass 71, which is 0.1 mole of chlorine. We have a 0.2 mole of dihydrogen and a 0.1 mole of dichlorine made to react here. So we have to say that the limiting reagent present in here is chlorine because it has a lower concentration rather than that of hydrogen. So the limiting reagent used here is chlorine. Yes, chlorine is the limiting reagent. Okay, I have written down here, and we have to find out the volume of hydrogen present here. So here 0.2 moles of HCl will be present. Okay, 0.2 moles of HCl is formed. We do know that 0.2 moles of HCl are present. So we could easily calculate the volume present by PV is equal to nRT equation. Okay, so PV is equal to nRT equation. V is equal to nRT by P. Okay, the number of moles present here is how much? 0.2. Am I right? 0.2 moles into R at a bar. It has to be set that pressure under 1 bar. Am I right? Yes, 1 bar pressure. So we will write the universal gas constant as 0.083 into temperature at 273 Kelvin by 1. Yes, we have completed this one. So 0.2 into 0.083 into 273, which gives the volume of 4.54 liter. This is correct? Yes, you have to calculate this one. 0.2 into 0.83, 273. Yes, I have calculated this one and found out to be 4.57 liter. And the correct option would be, yes, average, I mean approximately equal to the option number B, 4.54. The correct option is option number B. There are 4.5 liter of hydrogen has to be prepared to make at 273 Kelvin and 1 bar pressure. We have found out the answer. We will move on to our next question. So this is our question right here. Which of the following is not true for oxidation? Okay, which of the following is not true for an oxidation? So what do you mean by an oxidation? Addition of electrons, removal of hydrogen, addition of an oxygen atom, addition of an electronegative atom. These are all the explanation of an oxidation reaction. So, which is the wrong one here? They are asking which is the wrong one. So, the wrong one is addition of oxygen is the correct one. Okay. Addition of an electronegative atom, yes, that's 2 correct. Removal of hydrogen, yes. Removal of an electronegative atom, which is the false one, which is comprises of the reduction reaction, okay, which is the reduction reaction. So the correct answer would be option number A, okay. Moving on to our next question. The property of alkaline earth metals that increases with their atomic number is, okay. Properties of an alkaline earth metals. Okay, what are the alkaline earth metals? Beryllium, magnesium, calcium, strontium, barium. These are the alkaline earth metals. Am I right? Yes. So, in this alkaline earth metals, along the downside of the group, okay, along the downward group, we have that atomic radii will increase. Am I right? Yes, atomic radii increases down the group in alkaline earth metals. So, the bond, which means the bond order of the all elements in alkaline earth metals increases down the group, so that we get an increasing order from beryllium to strontium, okay. So here thereby we could say that the beryllium has the lowest atomic radii, magnesium hydroxide with calcium hydroxide and strontium hydroxide, okay. So we could say that the solubility of the hydroxides, okay, solubility of their hydroxide increases along the down the group, okay, in case of increasing atomic number. The correct option would be option number C, which is the solubility of their hydroxides increases in water, okay. Option number C is the correct answer. Moving on to our next question. For the reaction A plus B gives C plus D, delta H is equal to minus Qj. The equilibrium constant cannot be disturbed by. Yes, that's our question right down here. And the equilibrium constant, which is cannot be disturbed by what? Okay. So this is our reaction, which is A, which is a gas, plus B, which is also a gas, gives, it's a reversible reaction giving C gas plus D. Okay. So pressure does not any effect on this equilibrium state. So delta N is equal to 0, right? Pressure does not have any effect on this equilibrium state. So delta N is equal to 0. So the correct option will be increasing in pressure, right? Increasing in pressure is the correct option because pressure does not have any changes in the equilibrium constant. Moving to our next question. Yes, this is the part from biomolecules. Are you familiar with the DNA structure and its components? Okay. So, the primary structure in a nucleic acid contains bases like G, A, T, G and C. Okay, this is the primary base of a nucleic acid. Okay, we have to find out the corresponding chain which has to be found. Okay, that is our motive to here. And guanine tries to bond with which one? How can you explain this one? See, okay, guanine gives with cytosine, adenine gives with thymine, thymine gives with adenine, guanine gives with cytosine, cytosine gives with guanine. This is the nucleic acid base structure. So, guanine gives cytosine, adenine gives thymine, thymine gives adenine, guanine gives cytosine. Cytosine gives guanine. This is the nucleic acid base. So the correct option would be CTACG, which is option number C. Okay. Option number C is the correct answer. Our next question. Consider the following electrodes. Okay. P Zn2 plus, which gives 0.001 molar, Zn2 plus at 0.01 molar, Zn3 plus 2 plus at 0.1 molar, Zn2 plus at 0.001 molar. Okay, you have to find out the in above electrode potential, the volts are in the order. You have to find out the increasing order of the volt. Okay, you have to find this one. So we could say that in this thing, the highest number of concentration of the zinc ion is the most highest electrode potential. Okay, so in here the most highest one would be Q. Am I right? Q has 0.1 molar, following by R, which has 0.01 molar, and which has S with 0.00 molar, and lastly with 0.0001 molar. So it will give QRSP. Am I right? It is directly proportional to the concentration of zinc ion. Okay, electrode potential. So it could be answered by like this one, right? Zn2 plus, okay, in an aqueous solution plus 2 electrons give Zn. Okay, E reduction is equal to E0 reduction minus 0.059 by n. Okay, log 1 by Zn2 plus. So you have to find out the concentration of Zn. Okay, E reduction is equal to minus 0.76. Yes, we have given the electrode potential of the E0 Zn plus Zn2 plus as minus 0.76. We have given that by 0.059. Okay, by 2 moles. Yes, there are 2 moles with log 1 by Zn2 plus gives plus log Zn2 plus. So with this reaction we could say that electrode potential is directly proportional to the concentration of Zn2 plus ion. Okay, when Zn2 plus ion increases, the electrode potential also increases. So the correct option would be the greater one with 0.1 molar, which is QRSP. Correct option would be C. Okay, are you following with me? Let's move on to our next question. Yes, 11. C6H5CH2Cl when treated with alcoholic ammonia. Okay, alcoholic ammonia. What is that actually? When this C6H5, which is a benzyl chloride, when treated with alcoholic solution of ammonia, okay, we get a primary amine. Okay, we get a primary amine. We get C6H6. That's the ammonification. CH2NH2. This is a primary amine that is formed by any alkyl halide or an aryl halide. When treated with ammonia, we get a primary amine. We have studied on the first part of amines and its derivatives. So this is what our option A, the compound A is this one, CH2NH2. And with this, when treated with CH2Cl, am I right? Yes, CH3Cl. Okay, CH3Cl. We get ammonical CH3 N CH2N with CH3 twice, which is a NN dimethyl phenyl methanamine, right? Methanamine, NH3 2, right, CH2, N, CH3 twice, N, phenyl, dimethyl phenyl, right, sorry, we have two methyls, NN dimethyl phenyl, NN dimethyl phenyl methanamine, okay, methanamine. So this is the correct answer, which is option number A, 11A, NN dimethyl phenyl methanamine. We will move on to our next question, question number 22. A metal crystallizes in BCC lattice with a unit cell edge length of 300 picometer and a density of 6.15 gram per centimeter cube. The molar mass of the metal. As you know, the density of a metal or a solid structure or cube, metal cube can be determined by the equation with D is equal to what? Zm by A cube Na. Okay, are you familiar with this equation? Density of crystal is given by Zm by A cube Na, where Na is Avogadro number. Okay, so here you have to determine the molar mass, which is M is equal to A cube Na by D by M. Yes, sorry, Z. We do know that in BCC structure the Z value, number of atoms present in a unit cell is 2. So we could write A cube, which is 300 picometer. Upon converting into meter, we could write 300 into 10 raised to minus 10. Okay, 300 into 10 raised to minus 10 whole cube into edge length. Density is 6.15. Am I right? Yes, 6.15 into 6 into 10 raised to 23. Right? We are just trying to specify that equations into lower. 6 into 10 raised to 23 by, which is 2. Okay, we have to find out this one. Okay, we move on. 300 into 10 raised to minus 30 into 6.15 into 6 into 10 raised to 23. Okay, this is what we could cancel out this and this with 10 raised to 7, which gives us with approximately equal to 50 gram per mole. Alright, yes, 50 gram per mole. So the correct option would be option number A. Okay, we have to find out the approximate value for every and each reaction. That's it. Okay, so the correct option would be 50 gram per mole. We will move on to our next question. Yes. Choose the correct statement. KH value is same for a gas in any solution. Higher the KH value, more the solubility of gas. KH value increases on increasing the temperature of the solution. Easily liquefiable gas usually has a lesser KH values. So, you have to find out what are the correct statement for the term KH. What is KH? Henry's constant. Before knowing Henry's constant, we have to find out what is Henry's law. A pressure applied on a substance or a solution is directly proportional to its mole fraction of its constituents. Am I right? Yes. To remove this proportionality, we introduce a constant called Henry's constant, which is KH equal to Chi. Okay. So my question is, which is the correct statement for this one? KH value. Okay. So we could write that KH value is same for any gas in any solution. Okay. So that is wrong. KH value depends upon this solution. Higher the KH value, more will be the solubility. Okay. KH value changes with the solvent natures. Okay, so that doesn't refer. Higher the KH value, lower will be the solubility. Okay, so the second option is also wrong. KH value increases on increasing the temperature of the solution. As you know that if a temperature is increased on a solution, its solubility decreases. That's why in higher temperature or hot water, aquatic animals cannot survive because the dissolution of oxygen in water is reduced. So we could apply that Henry's law on here, so that the higher the temperature, lower will be its solubility. So we could say that KH value increases with the increases in temperature. So the option C is the correct answer. Okay. We will look after option D. We have found the correct answer, but we look at after D. Easily liquefiable gases usually has lesser KH value. Okay. Easily liquefiable gas have higher KH value. That's why it's liquefiable. So the option D is wrong. Correct option would be option C. Okay. KH value increases on increasing the temperature of the solution. Okay. Yes. Buckminster fullerene. Number of 6-membered and 5-membered rings present in the Buckminster fullerene. What is a fullerene actually? Have you ever heard of a fullerene? Yes, a fullerene is an allotrope of carbon, you know. It's a hollow sphere, football-like structure with the alternative 6-membered and 5-membered ring around this globe. Consider football. Okay. Football has this type, right? 6-membered ring with the 5-membered again. Okay, this is the primary structure of a fullerene. Okay, in this fullerene there are totally almost like they are here asking there what are the number of 5-membered and 6-membered hexagonal and pentagonal structures you could see in fullerene. So the correct option would be there are 12 6-membered. Okay, 12 6-membered rings and 12 5-membered and 20 6-membered 6-membered rings, carbon rings in Buckminster fullerene. So the option would be option number A. Okay. We will move on to our next question. Yes, this is organic based question. Okay. A, B and C are treated with different reagents here. Actually, this is HgS4, right? You can't see from this here. This is actually mercuric sulfate, okay? Mercury sulfate, Hg2SO4, okay? With oxidation number 2, HgSO4 and H2SO4, okay? And pyridinium chlorochromate and SnCl2HCl, okay? We all do know that pyridinium chlorochromate is an oxidizing agent, mild oxidizing agent which is used for conversion of alcohol to aldehyde. We have to find out here an acetaldehyde. What is an acetaldehyde? CH3CHO. Okay. You have to find out CH3CHO from an alcohol which has the same thing. So the alcohol might be a methanol. Am I right? There are two carbons. Two carbon aldehyde has to be formed from a 2-carbon alcohol. So correct. The option B would be an ethanol, right? Yes, ethanol. B is an ethanol. Okay. When ethanol CH3 CH2OH when treated with a mild oxidizing agent we get CH3CHO acetaldehyde. Okay. Are you familiar with this one? Oxidation of a alcohol. And we'll look after this A. HgSO4 and H2SO4. This is actually acidic hydrolysis of a triple bond. Okay, we have studied in the organic chapter aldehydes, ketones and carboxylic acid on the first part. Preparation of an aldehyde. We have studied that when a triple bond or an alkyne when treated with mercuric sulfate and sulfuric acid, we get an aldehyde. So the only triple bond found here is ethyne. Okay, we have to find out ethyne. H C triple bond CH. This is ethyne. Okay, which is the compound A. When treated with HgSO4, mercury sulfate and sulfuric acid, we get CH3CHO, acetaldehyde. Am I right? Yes. So A is ethyne, B is ethanol, and we have to find out C. So when C is treated with stannous chloride, which is SnCl2 and HCl. Okay, have you ever heard of any reaction, any named reaction where we use SnCl2, which is a stannous chloride? We use that stannous chloride in Stephen's reaction. Do you remember anything about Stephen's reaction? We have studied earlier that when nitrile, any alkyl nitrile when treated with stannous chloride with HCl, we get an aldehyde. There is a separate class of studies happening on aldehydes, preparation of aldehydes regarding this Stephen reaction. So when a nitrile, we could use this CH3CN, alkyl nitrile, when treated with what? SnCl2 with HCl. Okay, Cn HCl, we get CH3CHO. Okay, this is the Stephen reaction reduction, which is alkyl nitrile. So the correct option would be ethine, ethanol and ethane nitrile. So the correct option would be option number C. Okay, C, CH3CN. Option number C. This is ethyl nitrile. Okay, Stephen reduction. When a nitrile is reduced to an aldehyde. Okay, Stephen reduction, this one and last. Okay, we will move on to our next question. An organic compound X on treatment with PCC, pyridinium chlorochromate, in dichloromethane gives the compound Y. What is a pyridinium chlorochromate? We have earlier discussed that it is an oxidizing agent, mild oxidizing agent. Okay, when a pyridinium chlorochromate, when treated with dichloromethane, okay, when dichloromethane, we get compound Y. Compound Y reacts with I2 and alkali from a yellow precipitate to triiodomethane. The compound X is. So we have to find out what is Y. From that we have to find out X. Okay. We could also say that Y when react with I2 and an alkali. What is that I2? And a halogen and an alkali. Could say that it's an haloform reaction, right? Iodoform reaction. We have earlier studied that when a keto containing group with a methyl on the side, when treated with an halogen along with an alkali, we get an iodoform. Okay, so when this is when Y is treated with iodine, okay, sorry, iodine and alkali, consider NaOH. Okay, we get a triiodomethane, which is CHI3, triiodomethane. Triiodomethane is only formed when a haloform reaction is completed. So triiodomethane with what do we get here? HCOONA. These are the products when in a haloform reaction, triiodomethane. So here we have Y is CH3CHO. Okay, CH3CHO. This is the compound. So compound Y is acetaldehyde. Okay, from this acetaldehyde we have to find out compound X. This is when an organic compound X on treatment with pyridinium chlorochromate. So an alcohol is oxidized to form an aldehyde. So the correct option would be an CH3CH2OH. Okay, PCC and HCl, which gives CH3CHO. Okay, so the correct option would be option number C. Am I right? Yes, primary alcohol, which is ethanol, when treated with pyridinium chlorochromate, which is a Jones oxidation reaction. We have studied earlier in the preparations of aldehyde and also in reactions in alcohol. When an alcohol treated with pyridinium chlorochromate along with HCl, we get acetaldehyde right down here. Okay, this acetaldehyde is subjected to haloform reaction where and halogen is treated with an alkali which gives an triiodomethane with methanoic acid. Okay, so the correct option would be CH3 CH2OH. Moving on to our next question. In a set of reactions, identify D. Okay, this is our question. In a set of reaction, identify D. When an ethanoic acid treated with SOCl2, we do know that when during the preparation of acyl chloride, we have to treat it with SOCl2. So option A, compound A would be CH3 COCl. Okay, we have found that one. And when this acyl chloride is treated with benzene and anhydrous aluminum chloride, okay, anhydrous aluminum chloride, we could get, what is this actually? This is an Friedel-Crafts acylation reaction. Am I right? An aryl or an alkyl substituted when treated with acyl or aryl chloride in presence of anhydrous aluminum chloride. Okay, we could get what? CH3 CO C6H5. Okay, this is what it is formed, and this B is then treated with the HCl. Okay, HCl. How could be hydrocyanide reaction? Am I right? Cyanide reaction. Okay, so this could be written like this one: C double bond O C6H5. When a Cn minus ion it attacks at the carbon group, which becomes CH3 CO Cn CO minus C6H5. Okay, are you familiar with this one? Addition of an cyanide group on the carbonyl group, because the cyanide ion is a highly electronegative compound which attacks at the electropositive atom at the carbonyl group, which is at the carbon. It does not attack at the oxygen because it is electron rich, and we get O minus, which gives us what? CH3 okay, which gives us at IS Cn. Upon hydrolysis we get CH3 COH, okay, Cn C6H5. Okay, where do we have this one? Option number C. Isn't this correct? Okay, one second. Yes, we have to further hydrolyze it. Okay, further hydrolyze with, we could get what? C6H5 COH, okay, OH COH CH3. Okay, this is option number D. So the correct option would be option number D. Okay, so we will follow up with the next part. Okay, next part of the question. A compound A is insoluble in NaHCO3 solution but dissolved in NaOH and gives a characteristic color with the neutral ferric chloride solution. When treated with bromine water, compound A forms the compound B with the formula C7H5OBr3. A is what? You have to find out what is A. Okay, it's a quite long question actually. So a compound A C7H8, okay, compound A C7H80 is insoluble in sodium bicarbonate, which means it is an what? Alcohol. Okay, so we could say that option A, compound A might be an alcohol. We have benzene ring. H6 is completed. OH is here. Okay, we have remaining CH 3, okay, CH3. Yes, I think I have completed this one. Okay, when this is ferric chloride, yes, Br2 treated with bromine, we get tribromo product, Br around here, Br around here, OH, CH3, okay, tribromo product with here, this one, OH, Br. This is the product that is formed around here, and with this we could find out option A, which is C. Okay. Sorry, not C, it's B. Orthopara substituted, right? Yes, orthopara substituted alcohol and methane. So option number B. We'll move on to our next question. Dihydrogen when treated with silver chloride, we get a free silver with hydrochloric acid. That is our question right down here. And we have to find out what? E cell at 25 degrees Celsius for the cell is 0.22 volt. The equilibrium constant at 25 degrees Celsius. Yes, we have to find out the equilibrium constant. Okay, let me write down the reaction for this. Okay, when H2 is treated with 2AgCl, okay, we get 2Ag with 2HCl, okay. E0 cell at 25 degrees Celsius, okay, we have to find out E0 cell at 25 degrees Celsius is at 0.22 volt, okay. We have given the known data, okay. Equilibrium constant log Kc is given by E0 cell into N, okay, by 0.059, okay. Okay, we have done this earlier because E0 cell is equal to E0 by minus 0.059 by N into log Kc. We have exchanged those things and we have to find out log Kc. E0 cell is 0.22 and 0.22 into number of moles is equal to 2. There are 2 moles, okay. 0.059, yes. 0.44 into point divided by 0.059, which gives 7.45, okay, 7.45. Kc is equal to anti-log 7.45, okay, which is almost equal to 2.8 into something, 2.8 into 10 raised to 7, yes, which is option number A, okay. Option number A is the correct answer. Moving on to our next question. Let me remove this one. For a reaction A plus 2B gives products. When concentration of B alone is increased, half-life remains the same. If the concentration of A alone is doubled, rate remains the same. The unit of the rate constant for this reaction. See, this is a completely different question actually. Okay, chemical kinetics, we have never studied about this thing, but we have to think out of the box. That's the real reason here. Actually here, for a reaction, when the concentration of B alone is increased, half-life remains the same. So that the half-life is independent of the concentration. Okay. Which means that only reaction that is first order reaction which is independent of the concentration. So this is a first order reaction. We do know that this is a first order reaction, okay. We could write the first order reaction, okay. It's a first order reaction. If the concentration A alone is doubled, rate remains the same. The unit of the rate constant. We have to find out the unit of first order reaction, okay. We could also find a unit of first order reaction is second inverse. You know, rate of the reaction unit is given by mole liter inverse 1 minus n second inverse. This is the general formula of finding the unit of a rate constant. Okay, rate constant reaction. For a first order reaction, we could write n is equal to 1, which gives first order is equal to mole liter inverse 1 minus 1 second inverse, which is 0. Anything whole raised to 0 is 1. So the unit of the rate reaction would be second inverse. So the correct option would be option number A. Okay, 32A. Am I right? Yes. We will move on to our next question. The third ionization enthalpy is highest in which of these? Okay, third ionization enthalpy. How can we determine this one? Third ionization enthalpy. Obviously, it is alkaline earth metals, right? First ionization enthalpy, we could not, third ionization enthalpies, which is at the group 2 elements. Okay, so the correct option would be alkaline earth metals. Moving on to our next question. A pure compound contains 2.4 gram of carbon, 1.2 into 10 raised to 23 atoms of hydrogen, 0.2 molecules of oxygen atoms. Its empirical formula is, okay, we have to find out the empirical formula of this compound. Okay, we do have that there are 2.4 gram of carbon. Okay, so the given carbon would be, number of moles of carbon would be given mass by molecular mass, how much? 12. We get 0.2 mole of carbon. Okay, 1.2 into 10 raised to 23 atoms of hydrogen. Okay, we do know that there are 1.2 into 10 raised to 23 into 10 raised to 23 atoms of hydrogen. Okay, we get how much? 1.2 into 10 raised to 23 by 6 into 6.027 into 10 raised to 23. We could simplify by simply putting 6. We get how much? 0.2 mole. Okay, 10 raised to 3. Yes, it's actually 0.2 mole. Okay, 0.2 mole. And 0.2 moles of oxygen atoms. We do know that before finding the empirical formula, we have to find out the number of ratio of moles of each C, H and O. We have 0.2 moles of carbon, 0.2 moles of hydrogen and 0.2 moles of oxygen atoms. Its empirical formula would be CHO. Am I right? 0.2 moles is equal to 0.2 moles of hydrogen is equal to 0.2 moles of oxygen, which is 1:1:1 CHO. Correct option would be option number D, CHO. Empirical formula of this compound is CHO.